It's been on for a while.
All right. Before we get started, just a reminder that there is an edge elastic due tomorrow. Okay, there is an edge elastic out due tomorrow. And I guess yesterday I never really gave a due date for the makeup that we talked about yesterday. So, I mean, I it to be due today, but I never said that, I guess, so we can say that it's due tomorrow, right? Right, so the elastic, the weekly edge elastic is due tomorrow, and then also the air review with parallel and perpendicular lines will be due tomorrow, right? Today, then, we're going to talk about our final quadrilateral, a kite, right? So a kite has a few important properties over here. So just like when we talked about trapezoid, a kite is a completely separate shape. It is not a parallelogram, so bless you, it does not have any of the properties of a parallelogram that we talked about. Okay, it has its own properties. So a kite, okay, our definition of a kite is kind of up here. Exactly two pairs of consecutive congruent sides. So that means that there are two pairs of sides that are exactly the same, but those are right next to each other. Okay, so in this example, BC and DC have the same length, and then AB and AD have the same length. Okay, so a kite is a quadrilateral with two pairs of consecutive congruent sides. So then we've got a couple properties that follow from that. The first is that one pair of opposite angles are congruent. Okay? In this figure right here, the pair that would be congruent would be angles D and B. Right? And hopefully that's kind of obvious if we look at this figure. Okay? Angles A and C would not be the same, right? But B and D would be congruent. So, for example, if we say that this angle is 80 degrees, then this angle is 80 degrees. Okay? Now, we could actually find other angles in our figure knowing that information. We'll take a look at examples down here using that idea. Okay? The final property is that the diagonals are perpendicular. Okay? So we'll use that to find missing angles quite often in kites. Okay? We know that the diagonals form 90-degree angles. Right? So before I've been solving some problems, let's go back to that sheet that has all the properties on it. And we didn't fill in the trapezoid yet or the kite. So go ahead and get that out here. And let's fill in our hood and the kite. We did rhombus and a square. Yeah, we did the rhombus and the square a couple of days ago.
Oh, I forgot I need to get a new page.
Sure you don't want to
Sure, thank you for the offer, though.
What a nice guy. So genuinely caring. Always on.
Alright, so we need to fill in our properties for trapezoid and isosceles trapezoid, and then our new one for today of a kite. Okay, so what were our properties for any trapezoid?
circle.
Not a circle. So our definition of a trapezoid was just, it has exactly one pair of parallel sides, right? So that's kind of our first property here. One pair of parallel sides. We had one other property dealing with the angles that was true of any trapezoid. Do we remember what that one was? So we had one property for any trapezoid that dealt with the angles. What was that property?
Opposite.
Not opposite angles or congruent. Not opposite sides. So in an isosceles trapezoid, we said the legs were congruent. But in any trapezoid, our only other property was that consecutive angles are supplementary. And remember, we had one extra kind of caveat here that consecutive angles on opposite parallel lines are supplementary, meaning they add to 180. So remember, that was, for example, if I know that these two sides are parallel, that means that these two angles would add to 180. And then separately, these two angles would add to 180. Okay, that's what that property meant. Okay. So then, we talked about an isosceles trapezoid. Right, so I'll give you a second to write that one down for a trapezoid here. So right below that, then, we have an isosceles trapezoid. So what additional properties did we have for an isosceles trapezoid? Diagonals are congruent. That was one of them. Last leg. Sebastian? Non-parallel sides are congruent. So that was like these two sides here. Parallel sides are congruent. What else? These last two both had to do with the angles. Opposite angles are supplementary. That was one of them. And what was the final one? This one also had to do with the angles. And this one said the base angles are congruent. And by base angles, we mean angles that are on the same parallel line. So, for example, this angle and this angle would be congruent. So those were all of our properties for an isosceles trapezoid. So now we can fill in our final shape on this sheet. Kites over on the left side. A second to finish that one up. Sam and Case are the senior captains on the tennis team. So, and they're both here as my aides multiple times a day. So whenever they do something stupid, tally up. And that's how many laps they have to run on the first day of practice. So then they started counting for me as well.
So you have to run 40.
So yeah, I'll run. I'm up to
What's
laps.
what's
So they
the
gotta
DT?
write all that.
Only around yeah, just mark it. Okay, I didn't think I was just super like.
All right, so let's take a look at our last shape over here, the kite. So we just looked at these properties here. So first, we can say we know that we have two pair of consecutive congruent sides. Sides. Okay, so for example, in this figure, we can say this side and this side are congruent, and this side and this side would be congruent. Then we know one pair of opposite angles are congruent. So in this figure here, that would be this pair of opposite angles that are congruent. And then our final one is that the diagonals are perpendicular. Remember, this upside down capital T looking thing is our symbol for perpendicular. So that says diagonals are perpendicular. So we now have this list of all of our quadrilateral properties all filled out. Okay, so this is going to be a very useful tool as we start reviewing the chapter and studying for a test next week. All right. Any questions on any of that? All right, so let's go back to the note sheet then and try some problems dealing with these properties. So, in number one, I am given two angles in this kite, and I need to find the other two. So, one thing that I know is that I have one pair of opposite angles congruent. Okay, well, it's obviously not this pair of opposite angles that are congruent, so it must be this pair. Right? So I know that angles B and D would be congruent. If they're congruent, I can use the same variable to represent them, so I can call both of them x. Now, what do I know about all four angles in any quadrilateral? Okay. They add the 360. Okay? So if I know two of my angles here, I have a variable for both of these. I can say all four of these are going to add to 360. So do 85 plus 43 plus x equals 360.
Can't you do 85 plus 43, get the total divided by 2, be done.
Subtract that from 360, then divide by 2. Yeah. So if we add our like terms together here, we'll have 128 plus 2x equals 360. Subtract the 128 over. Get 2x equals 232. Thank you. Divide by 2. And we'll get x equals 116. Yep. So that means both of our missing angles here are 116 degrees. Okay with that one? Alright, so number 2 then, very similar idea, is what? It is a kite. This is a kite, because we could say that JK and LK are congruent, and JM and ML are congruent. So this is a kite. So which pair of angles here would be congruent? J and L. Yeah, so if L is 82, we know J is 82. So then we only have one other angle that we need to solve for. But we're going to use the same idea that we did over here. All 4 angles are going to add to 360. This time we only have one x, though. So I'm going to say 71 plus 82 plus 82 plus x equals 360. Add all of these together. So what is that? 164. What is it? 235. 235. So 235 plus x equals 360. Then all I need to do is subtract the 235 over. And we'll get 125. So angle K is 125. Alright, so we used a couple of ideas here. One, that we have one pair of opposite angles congruent, and also all 4 angles have to add to 360. Right. Questions so far? So now in the next few examples, they are kind of breaking the triangle up in, or I'm sorry, breaking the kite up into triangles. So if we look at number 3 here, we are given that angle QPT, just this angle right here, is 37 degrees. And from that, I want to find these 3. So first, I want to find PTQ. So that would be this angle right here. What would the measure of that angle have to be? 90, right? We know that the diagonals are perpendicular. That's one of our properties. So that angle right there is 90 degrees. Well then, I want to find the measure of angle PQT. So that's this angle right here. Well, now we can just look at this triangle. I know 2 of the angles. I know this one's 37. I know this one's 90. How can I find the third angle here? Add these together, subtract from 180. Right? Because I know all 3 angles in a triangle have to add to 180. So 37 and 90 would be 127. And then 180 minus 127 would get me 53. Thank you. So this angle would be 53. And then the final angle that we want to find is angle QRT. So that's this angle right here. What would the measure of that angle have to be? It would be 37, right? Because these 2 angles here are going to be the same. Questions? All right, let's take a couple of minutes then and have you guys try some of these. Okay, so 4, 5, and 6 deal with angles inside. So let's try 4, 5, and 6 here. Let's try 4, 5, and 6.
Just don't sound right.
Which one?
I started with that, but so this one.
Okay. For which one? So that would. So which one are you solving? So we know that this is automatically nice. Okay. So then first, you said 8 sides.
Okay. So this side and this side.
So the first one says we want X. We D, and then it says do the figure of option A. So if I know this is 59, that's 59. So this is what? First one. Then eight. So that's I think what you started trying to set up here. So plus 59. Now here we're just looking at this triangle.
We're trying to figure
So
out
those three measures of the Alright, let's take a look at the answers here. Okay, here are the answers for 4, 5, and 6. How did we do? Yeah, to be honest, using properties to set up the equation.
Hey, you ever seen this? Hey, you ever seen this movie?
I never have watched that.
I have watched it, dude. It's such a great movie.
What is it?
So, any questions on any of this stuff here?
No, I got it. Okay, USA.
Sweet. All right, so let's take a look then at a couple. Let's take a look at a couple of these down here. Right? These problems down at the bottom deal with Pythagorean theorem. So if I look at number 7, what I'm given is that Wx is 14, and then Wr is 8. From that, I want to find the length of Rz. Okay, well, in a kite, this diagonal will be split in half. So Rz will be the same length as Rx. So this is what I want to solve for. Okay, I can call this x. We know this is a right triangle because the diagonals are perpendicular. So to solve for a missing side in a right triangle, we need to use the Pythagorean theorem, which, again, is something you've seen before in previous classes, but we haven't spent a decent amount of time on it in here yet. Okay, we will. We'll do a lot of problems dealing with Pythagorean theorem later. Okay? But just so that we can see something like this now. In the Pythagorean theorem, A and B are the legs of the right triangle, meaning the two sides that make up the right angles. So here, my A and B would be x and 8. Between those two, it doesn't matter which one's A or B. So yeah, the 14 is the hypotenuse, and the 8 is one of the legs. Yeah, so my setup is going to be x squared plus 8 squared equals 14 squared. The hypotenuse is always c, yes. Alright, so to solve this, I'm going to square both of these. So 8 squared is 64, 14 squared is 196. Subtract 64 over. Get x squared equals 132. Then to undo a square, we take the square root. Okay, so this is something we can just plug into the calculator then. Okay, so the square root of 132, 11.489. Yeah, so we can go to two decimal places and say 11.49. So on the yellow calculators, the square root button is above the x squared button on the left side. It's the fifth button down. So you would hit second x squared to bring up the square root bar. So we're not going to spend a ton of time on Pythagorean theorem stuff right now. Okay, we're going to come back to this later in the year when we actually do Pythagorean theorem. Okay, this is just kind of so that we can see it now, so that it's in our heads. All right, so let's go ahead and flip over to the back. Okay, on the back, and we're going to start with number 11 because both 9 and 10 still have to do with the Pythagorean theorem. Okay, starting with number 11, we have some problems where we need to set up equations to solve for x and then plug that back in to solve for angles. Okay, so if I take a look at number 11, I'm given expressions for angles S and U. In this kite, what's the relationship between angles S and U?
They're equal.
They're equal, they're the same. Yeah. So how would I set up an equation? Yeah, just set these equal. Right? So 13x minus 32 equals 7x plus 22. Okay. Now, this portion of the paper is going to be your homework. So I'm not going to finish these problems. I'm just going to start setting them up. Right? Not that. So number 12 would be the same idea, right? Angles N and L would also be equal to each other. What about number 13 here? What's going on here?
So B and D would be congruent. So B is equal to 109.
Yep. B and D would be, congruent. So that would be 109.
So would you have to add 109 plus 109 and then add 5x plus 14 plus 3x plus 8 equals 360?
Exactly. Now we would add all four of these angles together and set that equal to 360. Right? So 109 plus 109 plus 5x plus 14 plus 3x plus 8 equals 360. Okay, all four angles would have to add to 360. What about something like number 14 here, where I'm given this angle up here and then this angle right here?
So you do 9x plus 1 plus 2x or 23x minus 7 and then plus 90 equals 180, and then you'd have to multiply that by 2 to figure out, or you'd have to multiply each of the angles by 2 to figure out that angle for U or S. But we're not doing that.
Oh yeah, So Gage said to start by setting up our problem. We need to add all three of these angles together and set that equal to 180 because these three angles are inside of a triangle. So I can say 9x plus 1 plus 23x minus 7 plus 90 equals 180. Solve for x and then plug that back in to find the measure of angle STB. Okay. So your homework is just these squares off of each